Okay, welcome back. I hope you have seen my previous video in which I'm explaining about semantic kernel, what it is, how it is working, and we're also talking about the features because of which semantic kernel is the first choice for most of the organizations, specifically the big companies like Fortune 500 companies. Now, if you already gone through that, this is the time we are going to get our hands dirty with semantic kernel and develop our first AI agent with semantic kernel. So let's get started without wasting time. But before we do that thing, I want you to get familiar with the semantic kernel SDK. And I also want you to know the answer of this question, which is why we are going to use semantic kernel with Foundry agent service. Now we have seen that how to create agent using Foundry agent service. We have also seen that Foundry Agent Service is capable of integrating with multiple tools, knowledge tools, action tools, and a couple of other things. Now, we are going to combine both of these things now. Your Azure AI Agent Service, which we have available in Azure AI Foundry portal, is a comprehensive platform for agent development. It's actually created for that purpose only. And so why we are going to use semantic kernel with that? Because it's going to extend the existing investment in semantic kernel development to Azure AI agents. It's going to build solutions that leverage strengthen of different kind of agent with consistent code base with that. And it's also going to help you to integrate Azure AI agents into a multi-agent solution. We are going to see this, that how we can actually create a multi-agent solution, how we can orchestrate with multiple agents in the coming labs. Next, another cool feature, which I have mentioned in the previous video also, but now we are going to see this thing practically, is semantic kernel has something called plugins. In semantic kernel, plugins are nothing but functions that play a similar role to a custom tool function kind of thing. So if you remember that lab which I have done in which I was creating a custom function and then I was integrating and invoking that custom function in my agent, plugins are actually doing more or less similar kind of work with very much ease and with the dependency injection, because these things are going to be injected into that at runtime. So if you want to define a plugin class, first you do that thing, and then you're going to have a containing methods functions also inside that to annotate that this is not a normal function, this is a kernel function. Remember, kernel function is actually something which is a decorator. Now, I hope you know decorator if you have used languages like TypeScript and all. But if you don't know, in JavaScript, TypeScript and all, decorator is basically some kind of a label which you're adding on top of a normal function. So think about this. You have created a normal function, and now you want to use it with semantic kernel. Then all you're going to do is on top of that function definition, you're just going to put one label that it's a kernel function. When you do this thing, that kernel function is going to make this piece of logic, which is going to be treated as a plugin. So basically, this is going to be working like a plug and play kind of a logic. Your semantic kernel is capable to do this thing just by adding this one single word, which is kernel function decorator. You can add the plugin to the agent's plugin properties so that it can be identifying, and then you can call the functions as and when you need. Well, it sounds complex right now, or you're getting confused with this. Don't worry. In our first lab, we are going to create one agent with one function. And once you're comfortable with that, we will create multi-agent with multiple functions. So stay tuned. Let's get started with the lab environment. And I hope you already have Visual Studio Code, you have Azure CLI installed, you have Python installed. Now, all the things which we have discussed in our previous videos, that this kind of labs are actually requiring this lab environment, I hope you have configured that thing. And if you have done this, let's move to the Visual Studio Code. Now, remember, this is also one of the official lab of AI 102 course. So the link of this particular lab is visible on the screen right now. And if you're watching this video in YouTube, then you will be able to get that thing in the description of the video. This lab is actually having step-by-step configuration inside this, and it's managed by Microsoft. So we do not have a full control on this thing. But yes, let's focus on the Visual Studio Code specific logic now. Okay, I have cloned one repository. So guys, this is a repository which we have used in the previous lab also. This is the same repository which has multiple lab samples available in this. In the previous video, I have used this one, which is Azure AI agent function. And now I'm going to use this one, which is lab number 4, semantic kernel. And inside that, we have a Python folder. The first thing which I'm going to do is I want to go into this particular Python folder and I want to open this in the integrated terminal. Now, this is that particular folder where I'm going to execute my commands for pip install and other configurations which are required. So let me just do that thing first. And when I do pip install, logically, I don't need to do this thing right now because I have already installed all the required things. But still, there are chances certain things are required here additionally. So I'm just going to do that thing because this lab is going to use semantic kernel. So this time, the first thing which I'm going to do is in this folder, I'm going to say pip install with the Python.NET environment, Azure identity, and I need one more thing, which is semantic kernel. Remember, this is the first step of my lab, and this is actually going to install the Semantic Kernel SDK inside this. I'm also adding a parameter here, which is upgrade. So if something which is already there is going to upgrade to the latest version. I'm hitting enter, and this is going to take some time to just do this installation. Now, this installation is going to be done very quickly. I think it's collecting, it's downloading certain things, and very soon it's going to show me that it's done. Now this is the final step where it is installing all the collected packages now. You can see there is a lot of things which are getting installed right now in this. And the coolest thing is I just have to fire one command for this. So that's fine. Now I think this is taking a little longer. So instead of waiting for this, we can do one thing. We can actually create our Azure AI Foundry project meanwhile. So let me just go back to my browser. This is my browser where Azure AI Foundry portal is already open. I have already logged in with my account. What I'm going to do is I'm going to click on create an agent, which is basically going to create my project. And I've already explained this thing a couple of times that I always add a proj at the end of the project so that I know this is my project. And I always choose my favorite region, which is Sweden Central. So that's exactly the same what I'm going to do. I'm OK with all the configuration, and I'll click on create. Now, this process will take some time. And once this particular project creation is done, it's basically creating the Azure AI Foundry resources and some other configurations in the Azure portal. So you can go to portal.azure.com instead of ai.azure.com. And then that is the website where you can check these resources. I'm just going to wait for a few minutes because this is going to create the project. And then it's going to ask me that which language model I want to deploy for this. For this particular sample, I'm going to use GPT-4o. So this is the same one which I'm going to use in all the other samples also. So that is perfectly fine. Now, let me just check my Visual Studio Code. If this is still done, no, it's still going on. So there are two different processes which are going on side by side. And we are OK with that. We have nothing to do. We just have to wait. OK, I think my project creation is actually done now. So obviously, it's asking me which model I want to deploy. I'm going to select GPT-4o as I discussed. I'll click on confirm, and I'll just make sure that my TPM is 50,000 tokens per minute and it's deployed in Sweden Central. I'm all good with this. I'm just going to click on deploy. And within few seconds, it's going to be done. Yep, it's done. It's showing me my agent's playground. And inside that, my one agent, which is agent 480, is something which is actually created. Now remember, the same agent is going to be visible in this agents section also. So I'm just clicking on agents, and this is the default agent which got created. I'm not interested in this. I'm interested in the agent which I'm going to create through my code first approach using semantic kernel. So let's keep it here. But we need two things. We need two things from this particular project. I need my project endpoint. So I have to go to my overview section, and I'll just take the project endpoint, which is this. So I'm just copying this, going back to my Visual Studio Code. I think by this time, you can see the installation is also something which is done. So this is showing me that certain things are actually done, certain things are not done. But yes, it said successfully installed most of the packages, which is fine. I'm happy with this. I'm going to my project folder, and inside that, we have an environment configurational file. I'll keep my Azure AI agent endpoint. So this is actually my project endpoint, which I have already copied. So I'm pasting it here. And it's asking me my model deployment name. Now, my model deployment name is actually GPT-4o. So this is the name of my model, which I have created, and I'm going to save this. Just remember, guys, if you are not sure which model you have used, you can go to this section in the left side, model plus endpoints. And if you go there, this is the name of your deployed model, which you have to choose. Also, do not make a typing mistake. This is GPT-4o, not 0. This is not GPT-40. This is GPT-4o. I'm choosing this, and I have given this GPT-4o name here, which is perfect. If that is done, the next thing which I want you to observe is, let's focus on what kind of agent we are going to create. Right now, I have one file in this project, which is data.txt. This data.txt is actually having some kind of a expense claim details. Yes, we are again going to create an expense agent, which is basically helping me to submit my expense claim. You can see I have some data, which is date, description, and amount. 3 columns are there. And on this particular date, on this particular item, we have spent this much amount, is what we are trying to showcase in this expense details. Now, this data.txt is what I'm going to use while submitting the expense claim. And what I want my AI agent should take this data, and based on that, it should help me to submit my expense claim. It can maybe send an email to a specific email ID in my organization, so that that claim is going to be processed based on that. This whole process is going to be done by my agent. I'll show you more details about this in the configuration logic. But right now, I'm going to my semantic kernel.py. This is a file which is actually going to have my step-by-step logic inside this. I'm going to take this logical code from that URL, which I have shared with you. So just make sure, guys, this is the URL, which is actually going to have an access of the configuration. So basically, all the steps are available in this URL. Just make sure you are going to follow that. Also, when you are following this thing, just take care of the logical indentation of the Python code. So just make sure you're going to take care of this also. I am going to start with adding a reference in this. So the first thing which I have to do is I'm just going to take certain references, and these are also very important. Because we are going to use semantic kernel this time, you can see I've started with something like .NET environment, Azure identity with the default Azure credentials. Semantic kernel.agents and semantic kernel.functions are the new libraries which we are taking right now. Semantic kernel agents is that particular thing which is helping me to integrate with my Azure AI agent. And that's why it has classes like Azure AI agent, Azure AI agent settings, and Azure AI agent thread. As well as we have one particular thing which is kernel function. This is that decorator which I was talking about. This decorator is going to help me to treat my custom function logic as a plugin, and then I can use it anywhere. And we also have one annotate which is actually coming from typing. So these are the namespaces which I have added on the top of this particular project. Now, if I show you the initial code of this particular file, let me just get rid of terminal. We are first trying to take that particular data from data.txt. So we are trying to read the file, and then whatever data which is coming from that particular file is what we are going to use here as processing this particular data. I'm having a user prompt here, which is saying that here is the expense data in your file. What would you like to do with it? And then this is something which is my initial input, which I'm asking for a prompt. Then that user input and the data file, which is having the data which is read from the file, is actually going to be added into this particular function, which is called process expense data. How I want to process this expense data, that is important because that is what which is going to be done by my agent. We have a couple of commented lines section available here. I'm going to take the first one, which is going to create a plugin for the email functionality. So basically, before I do any of those things, I actually have to focus on creating a plugin for email functionality. Now, logically, I have to write an SMTP kind of a code to send an email. But as of now, I'm not wasting my time in this. I have one particular logic here, which is a class called email plugin. And this is actually going to have an email functionality inside a function called send email. Now, if you check my send email function right now, it's just having some particular parameters like self, to whom you want to send email, the subject of the email, and the body of the email. And this whole thing, we are just going to print. We are not going to write an SMTP code right now because sending an email through code is something which everyone knows. So we are not focusing on that code right now, and we are not focusing on sending email actually. But whatever data which we are going to send in the email is going to be printed in this particular application right now. Above this, the most important line which I want you to observe is we have one decorator, which is kernel function. If you ask me what is the difference between this function and normal function, the thing is this @ symbol. Whenever you see @ symbol and some function call which is happening here, remember this is just an additional label which you're adding on top of your normal function. So the logic of the function is totally common. It's a normal logic. But above this, the moment you add that this is not a normal function, it's a kernel function. then semantic kernel knows that this is going to be treated as a plugin, and then you can use it throughout this thing. So you can see right now it is mentioned in the description of this thing that this decorator is used to mark a function as a kernel function. It also provides some metadata for the function, and the name and the description can be left empty. But in our case, we are specifying one description that this is actually going to send an email. So I'm just providing this kind of a simple description with this. Now, once I have an email plugin created, I can use it in my agent. How? That's what we're going to see next. In order to do that thing, first I have to get the configurational settings file. So I'm just going to provide that code here. I'm pasting these 2 lines of code, which is basically loading the .NET environment and initiating the Azure AI agent settings. Remember, this is also a class which is coming from Semantic Kernel.agent. So we are not using Azure AI Foundry SDK right now to create an agent. We are using Semantic Kernel to create an agent with Azure AI. And once I do this thing, a variable which I got, which is AI agent settings, is the most important variable for me. This variable is going to help me to configure my agent. And that's what we're going to do in the next thing. So in the next step, we are going to connect to the Azure AI Foundry project now, and that is a place where we have to use our configurational values which we have stored in that. So basically, if you check right now, I'm using default Azure credential. I'm specifying my credentials inside that. I'm specifying my properties like exclude environment credentials and manage identity credentials kind of things. And then finally, after this, I'm providing a project client. This project client is nothing but one particular variable which we are specifying here with this configuration. So this whole object is going to be stored as project client in this. After this, I want to define an Azure AI agent that is going to send an expense claim email. And if I want to do that thing, this time we are creating an agent using the function which is called create agent. Remember, this project client object which we have created here is actually going to be used here. So I'm specifying that my expense agent definition is actually going to be a project client dot agents dot create agent. This is basically a function which is helping me to create a new agent. And this is something which you have seen in the previous samples also. It's the same kind of a function, but this time it is taken care by semantic kernel. While doing this thing, I'm passing my model, which can be my settings.model.deployment name, which is GPT-4o in our case. I'm giving a name of the agent, which is expense agent. So when the agent is successfully created, this name we have to look into a Foundry portal so that we can actually check whether the agent is available or not. And the instructions which I'm providing is actually like this. I'm saying you are an AI assistant for expense claim submission. When a user submit expense data and request an expense claim, use the plugin function to send an email to this particular email ID, which is expenses@contoso.com, with the subject, which is going to be expense claim, and the body that contains the itemized expense with the total. So basically, the itemized expense is something which we are going to provide through data.txt, but there is no total in data.txt. That is maybe a logical execution which is going to happen in this, and it's going to do the total of that. Then confirm to the user that you have done so. So basically, the email is sent successfully. That's what you're going to send as a confirmation to the user with that. And this is what this agent is actually going to do. Remember, in this particular sample, we are using only one kernel function, but we can have multiple. And that kind of sample we are going to create exactly after this in the next video. But yes, right now we have simplicity, and that's why we have only one kernel function. After this, it's a time we have to create a semantic kernel agent. So this is now, which is going to be that code, which is different. And this is the one which is actually going to create an agent. So this is creating agent, which is just creating a configuration file for that. So you can see it's all stored in this variable called expense agent definition. If I focus on this thing, this variable, which I've created here as an expense agent definition, is getting associated with my next function call. So if you see, Azure AI agent is actually that particular class which is helping me to create Azure AI agent using semantic kernel. And while creating this thing, I am specifying that this is my project client, this is my definition of the agent which I have defined here, and then I'm specifying that this agent is always going to associate with the plugin. Which plugin? The email plugin. Now remember, this is an array. The plugins property is actually capable to handle multiple plugins. I'm only adding one right now, but it's an array. I can add multiple plugins, and all of those plugins will be associated with your agent. That's how easy it is. Last and the final thing which I want to add on here is I want to use the agent to process the expense data. And that code is going to look like this. Let me just take care of the indentation by hitting 2 tabs. And now if you focus on this particular code, this is actually taking care of everything. Like you're first going to initialize the thread, which is going to take care of the user and the conversation which is happening with that. Then we have a simple try, catch, finally kind of a block. We have a try block in which we are trying to get the prompt message with the expense data. And then we are going to specifically try to get the response from the agent. Whatever response we are getting, we are going to associate that with particular thread. And then that response is going to be stored in this variable, which we are trying to print. If something goes wrong, we want to catch that exception and we want to print that. And finally, if everything is going well, we are going to delete the thread at the end of this, and we want to delete the agent also. So this is basically 2 lines of code, which is deleting agent and deleting thread if everything is done. Now, if all this code is done, I'm just going to save this file. I already saved this file just now. And if this is done, I want to see whether this is working or not. And that's why I am going to execute one command, which is going to run this sample. So I'm going to say Python semantic kernel.py. This is going to run my application. Remember, guys, if you are doing this thing in the separate computer, you have to do AZ login before this. I've already done this thing, I think, earlier today morning, so I don't need to do it again. But if you are doing this thing first time, you have to do AZ login. You have to authenticate with your Azure subscription. Then only it will allow you to find that particular service. I'm going to say, what would you like me to do? I'm saying I want to submit an expense claim. And when I hit enter for this, it's going to check the details for the submitting an expense claim kind of thing. And let's see what it is doing. It's going to invoke my function. It's going to associate with the send email kind of functionality. And yep, it's showing me here that we are sending an email to this email ID. Subject is expense claim. Please find the below itemized expense and total. It's showing me the itemized expense, and it is doing the total also, which is $215.40. Now, this is something which is my response from the expense agent is saying that your expense claim has been submitted successfully. The email with the itemized expense and the total amount has been sent to this particular email ID. This is how the agent is actually working right now. Now, as of now, a tricky question for you, everyone. If you are focusing on this video so far in this, just do let me know. Right now, if I go to my Azure AI Foundry portal, and if I try to refresh this, will I get my new expense agent? Yes or no? Just pause this video. Think about this question. Will I get my expense agent here if I refresh this thing? Because in all previous videos, we always got that. Now, I hope you decided your answer. If I refresh this, you can see I'm not getting any expense agent. Why? Because in my logic, I have written this code in such a way that if everything is done in this finally, I'm just going to delete the thread and I'm going to delete the agent. If you want to see this agent in the portal, you have to just comment this line and then run this application once again, and you'll be able to see that agent and the execution which happen with the thread. Right now, this is the whole thing which is actually happening with the semantic kernel, and we just created one single agent with one single plugin, and this is how it is working. I strongly recommend you to understand this logic first before proceeding to the next sample, which is actually going to create a multi-agent kind of an application with semantic kernel. So just make sure you do this thing practically. Only theory is not important. Important thing is you understand what we are doing, and you should be also able to do this thing by yourself. Okay, so I hope it's making sense. And because this is the end of this particular video, I want to remind you that if you have still not subscribed to our YouTube channel, please do that thing. And you can visit skilltech.club, which is our website. It's visible on the screen right now. And that is a place where you can get all the Azure and AI related learning courses. Most of the courses are actually free. There are some premium courses also, and there is a premium subscription. If you go for that, we will be able to help you, mentor you, will be able to provide certain labs to you, will be able to help you in your interview preparations, and many more. So let's get connected. Thank you so much, guys. I'll see you tomorrow with another sample. Bye-bye.